Hello everybody and welcome back to another visual pattern challenge. Here is our visual pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of little squares in step 4. If you can do that, can you predict the number of squares in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? That's the challenge. If you'd like to accept it, pause the video and work it out. All right, so this pattern seems to be growing in a pretty steady and modest rate. It doesn't get too much bigger from step to step. So just looking at it, my first impression is this is probably linear. But let's take a look. I think, and it looks like it's growing. We've got sort of a square or half of a square with a diagonal in it, and it looks like it's getting bigger on all the either end and the diagonal. I think what I'm going to do is try to find this pattern in here, and it looks like it's that. Yeah, those two are the same. So what has been added here is 3. Then if I try to find this pattern, there it is. Yeah, that's the same as this one. And again, we've added 3, 1 at each end of the sort of the arms of the square, and then 1 at the diagonal. Okay, so if I were to predict step 4, I would just add another square here, another square here, and another square here. How many would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I think there are going to be 16 in step 4. Let's just analyze the numbers quickly here and verify that my hunch that this is linear is correct. So I'll put the step number and the number of squares. So in step 1, we've got 5, 6, 7. And in step 2, that's 10. And in step 3, that is 13. And in step 4, we're saying 16. And then if we take the difference between each step, 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3. Yeah, we've got a constant for our differences. And this should make sense. We've been adding 3 every step, so the difference between steps should be 3. When the difference between steps is a constant, we know it's a linear pattern. And we can use the equation for a line to model that pattern. So here's y equals mx plus b. The m, the slope of the line, is going to be this rate of change between each step. So we're going to start with y equals 3 times x. X is going to be our step number, and y will give us the number of squares. This plus b, we need to figure it out from what's up on the screen here. So let's just try y equals 3 times, and we'll plug in step 1. If we did that, 3 times 1 is 3. There are more than 3 squares here, and looks like there are 4 more than 3, so we'd have to add 4. So that should be what our b is, and our total equation then would be y equals 3x plus 4. But let's test it. So in step 2, that would be 3 times 2 plus 4. 6 plus 4 would be 10. Yeah, that's how many in step 2. How about step 3? 3 times 3 plus 4. 12 plus 4 would be 16. Oh, sorry, that's 3 times 3 is 9 plus 4 is 13. So yeah, that would be 13 in step 3. So that works out. Okay, so our equation y equals 3x plus 4 appears to be working. We can use it now to calculate the number in step 43. So y equals 3 times 43 plus 4. 3 times 43. Well, 3 times 40 is 120, and 3 times 3 is 9, so that's 129 plus 4. So that should be 133 little squares in step 43. Well, how did that go for you? Did you get 16 in step number 4? Did you get an equation like this? Let me know. Thanks, everybody.